Good morning, champs. Today we solve section forces in a bent beam. This problem is more advanced than the previous straight beam example because the structure contains an inclined member, a horizontal member, and an externally applied couple. The force is 24 kilonewtons. The applied couple at B is 36 kilonewton meters clockwise, and the reference length L is 1 meter. The inclined arm makes an angle of 120 degrees with the positive horizontal direction. We divide the structure into three regions: the inclined arm, the horizontal member between A and B, and the horizontal member between B and C. Before making any cuts, we calculate the support reactions. Horizontal equilibrium gives AX equal to 24 kilonewtons to the right. Vertical equilibrium gives AY plus CY equal to 0. Taking moments about A, counterclockwise positive, gives therefore CY equals 3 kilonewtons upward and AY equals negative 3 kilonewtons. The negative result means the actual vertical reaction at A acts downward. Now we analyze the inclined arm. This is where local coordinates become important. Axial force and shear force are always defined relative to the direction of the member. The force is horizontal in the global coordinate system, but it is neither purely axial nor purely perpendicular to the inclined member. The arm length is 1 divided by the sine of 120 degrees, which is approximately 1.155 meters. Resolving the force relative to the member gives a parallel component of 12 kilonewtons and a perpendicular component of 20.8 kilonewtons. Let S be measured from the free end toward A. With the sign convention shown on the board, the axial force is 12 kilonewtons, the shear force is 20.8 kilonewtons, and the bending moment is negative 20.8 times ACE. The important lesson is that a globally horizontal force can produce both axial force and shear force when the member is inclined. Next, we cut the horizontal member between A and B. Let X be measured from A. Horizontal force equilibrium gives an axial force of 0 because the applied horizontal force and the horizontal support reaction cancel each other. Vertical equilibrium gives a constant shear force of negative 3 kilonewtons. Moment equilibrium gives M equal to negative 24 minus 3x. Therefore, the bending moment is negative 24 kilonewton meters at A and decreases linearly to negative 30 kilonewton meters immediately to the left of B. At point B, a clockwise couple of 36 kilonewton meters acts on the structure. A concentrated couple does not create a jump in the axial force diagram or the shear force diagram. It creates a jump only in the bending moment diagram. Immediately to the left of B, the bending moment is negative 30 kilonewton meters. Crossing the applied couple creates a positive jump of 36 kilonewton meters, so immediately to the right of B, the bending moment is positive 6 kilonewton meters. Finally, we analyze the region between B and C. Let theta be measured from B. The axial force remains 0 and the shear force remains negative 3 kilonewtons. The bending moment is 6 minus 3 theta.